Okay, let's look at a rate problem that's a for response. And this is with your calculator. This says the rate at which people enter an auditorium for a rock concert is modeled by the function R. So this equation R is a rate. The units are people per hour. There's no one in the auditorium to start at time 0. The doors close and the concert's going to begin at time t equals 2. So how many total people are in the auditorium? So remember, if I give you a rate, if I want the total amount, we are going to integrate the rate. And I want to know just when the concert starts, so it'd be from 0 to 2. So we're going to integrate R of t dt. And again, check for yourself that your units make sense. This is people per hour. The units on dt is a small change in time, so this gives you total people. So this is my setup of the definite integral, and it's a total of 980 people. Okay, next question. Find the time when the rate at which people enter is a maximum. So the rate at which people enter, right? This is the equation R of t. So this is asking when is R of t, and if they don't put a word in front, remember it means absolute. So the question is, when is R of t an absolute maximum? When do you have a time value? So think about if I ask, when is f of x, do you have an absolute max? Step 1 is we take the derivative set to 0. So I'm going to take the derivative of r prime, and set it equal to 0. Use your calculator and set your window up just to go from 0 to 2, because that's the only time interval we're talking about. And you're going to see that this only happens at 0 and at 1.36296. And I'm going to call this number A. So step 1, in y1, type in the original. In y2, have it graph the derivative. In y3, have 0, and find the intersection points. And store this number as A. Okay, I need absolute. So what do we do with my critical numbers and my endpoints? We plug it back into the original function, which is R. So I need to know what is R of 0. What is R of A, this number that we just came up with, and then the other endpoint is R of 2. So R is given here. So just use your calculator and plug in those 3 time intervals. This is 0, this is 854.52 something, this is 120. So the biggest number is 854. So the time would be at 1.36296, and this is when the maximum occurs. This is enough justification for this problem. The other way you could justify this problem is you could say R prime of t changes from positive to negative at t equals 1.36296. Now this justification is typically for a local, but in this problem, since there was only one critical number, if the graph goes from positive to negative, the local max also happens to be your absolute. So that's the only reason this justification works here. Okay, last part. It says the total wait time for all the people in the auditorium is found by adding the time each person waits, starting at the time the person enters the auditorium and ending when the concert begins. The function W is the wait time. So they give you an equation for W, which is the wait time for all the people. The derivative of W is given by W prime, and they give you the equation. It's 2 minus t times R of t. I want you to find W of 2 minus W of 1, which is the total wait time for those who enter the auditorium after time t equals 1. So this is what I'm given, W prime. I'm trying to get to W of 2 minus W of 1. So think about what you're trying to get to. I'm trying to get from here to here. Well, if I have W prime, I'm trying to get to W. The only way that can happen is if I take the antiderivative. So first step is trying to figure out what operation I'm going to perform. So I'm going to take the antiderivative of W prime, because that will give me W somehow. But notice I've got numbers in here. I got W2 minus W of 1. Well, I want to use 1 to 2 as my bounds, because those are the numbers that I want. And what's the antiderivative of W prime? It's W, and what do we do with the upper bound? Plug it in. subtract off the lower bound. So this is just really asking, do you understand in order to get to this, this is what you're trying to do. So this, you can just type in your calculator. It's just 1 of 2, and then this is just 2 minus t times the r of t equation from before. And you end up with 387.5 hours on your calculator.